Welcome to EduCasts, home of EduCasters. If you walk into any classroom in America, from a kindergarten circle time to a university lecture hall, you're going to see teachers trying to get information to stick in their students' brains. It's the fundamental goal of the job. But for decades, we've been bogged down by myths and halfway correct ideas about how that sticking process actually works. We've all heard students say, "I'm a visual learner," or "I need to hear it to get it," while well-intentioned. These labels often miss the bigger picture of how human cognition actually functions. The reality is far more interesting and, frankly, a lot more practical. It brings us to a concept that has stood the test of time, backed by cognitive science and empirical research: dual coding theory. Dual coding theory, or DCT, isn't just some dusty academic idea meant for textbooks nobody reads. It is the blueprint of how our minds handle information. Developed by Paivio in the early 1970s, it provides a robust framework for understanding how we encode, store, and retrieve knowledge. The gist of it is deceptively simple. We have two separate but linked channels for processing information, one for words and one for images. When we use them both simultaneously, we don't just add to the learning, we multiply the chances of that learning taking root. We are going to tear down the engine of dual coding theory to see how it works. We will look at its origins, the mechanics of the brain's two-channel system, why it creates stronger memories, and most importantly, how educators can use this to turn average lessons into unforgettable ones. We are going to avoid the jargon where we can and stick to the brass tacks of teaching and learning. To really get a handle on dual coding, we have to step back to the psychological landscape of the mid-20th century. For a long time, psychology was dominated by behaviorism, the idea that we should only study observable behaviors. But by the 60s and 70s, the cognitive revolution was in full swing. Researchers wanted to open the black box of the mind and see the gears turning. Paivio, a researcher at the University of Western Ontario, proposed something that seems obvious now, but was groundbreaking then. He suggested that the human mind has two distinct subsystems for handling information. One, the verbal system. This deals with language. It includes the words we hear, the words we speak, and, crucially, the words we read. Two, the nonverbal visual system. This deals with images, spatial orientations, and mental objects. Paivio called the basic units of the verbal system logogens and the units of the visual system imagens. You don't need to memorize those terms to be a great teacher, but you do need to understand the distinction. Here is the common tripping point. Many people think reading text is a visual activity because you use your eyes. Under dual coding theory, that's incorrect. When you read a paragraph in a textbook, your brain processes that as verbal data. You are decoding symbols into language. It occupies the verbal channel. Looking at a diagram of a cell, however, occupies the visual channel. Paivio's theory posits that these two systems are functionally independent. You can listen to a podcast, verbal, while walking through a familiar neighborhood and visualizing the route, visual without much trouble. However, they are also interconnected. We can switch back and forth. If I say the word elephant, your verbal system processes the word, but your visual system almost immediately conjures up a picture of a large gray animal with a trunk. That link between the word and the image is what Paivio called a referential connection. This architecture is the foundation of everything that follows. It suggests that our brains are not just empty buckets waiting to be filled with whatever. They are sophisticated dual processors. The math of memory, 1 + 1 = more than 2. Why does this matter for a 10th grade history teacher or a corporate trainer? It matters because of how memory traces are formed. Think of your long-term memory like a massive, sprawling library. If you put a book, a piece of information, on a shelf, you need a way to find it later. If you only use the verbal channel, say a lecture with no visual aids, you are creating a single pathway to that information. It's like indexing a library book only by its ISBN number. If you forget that number, the book is lost in the stacks. Now, imagine you use dual coding. You explain the concept verbally, but you also provide a relevant image or diagram. Now, you have encoded that information in two places. You have the verbal memory trace and the visual memory trace. In the library analogy, you now have the ISBN number, but you also know the color of the book's cover and the shelf it sits on. If a student forgets the exact words you used, the verbal trace, the image might trigger the memory of the concept, which then helps retrieve the words. This is the additivity hypothesis. Having two codes is simply better than having one. The two codes reinforce each other. Concrete versus abstract. This also explains why concrete words are easier to remember than abstract ones. If I give you a list of words like table, horse, apple, and truck, you can easily dual code them. You hear the word apple and you see a red fruit. But if I give you a list like justice, truth, democracy, and irony, it is much harder. These are abstract concepts. You can process them verbally, but generating a specific, consistent mental image for irony is tough. This is why abstract concepts are harder to learn, and why educators have to work twice as hard to create visual metaphors for abstract ideas. When we use dual coding effectively, we are essentially building a safety net for our students' memories. We are giving them multiple hooks to hang their knowledge on. The learning styles trap. We need to take a detour here to address the elephant in the room. A lot of teachers hear verbal and visual and immediately think, oh, this is about learning styles. This is VARC. Let's be crystal clear. Dual coding theory is not learning styles. The theory of learning styles suggests that some students are visual learners who learn best with pictures, while others are auditory learners who learn best by listening, and so on. The implication is that we should tailor instruction to the student's preference. The scientific consensus, however, has largely debunked the idea that teaching to a student's preferred style improves outcomes. In fact, pigeonholing a student as a visual learner can actually be harmful if it limits how they engage with material. Dual coding theory asserts that everyone, regardless of their preference, benefits from combining words and pictures. The human brain, generally speaking, is hardwired this way. Even a student who swears they prefer listening to lectures will learn the material better if that lecture is accompanied by relevant visual support. We are all visual learners, and we are all verbal learners. We are dual coders. The goal isn't to match the teaching to the student's personality. The goal is to match the teaching to the human cognitive architecture. Cognitive load and the bottleneck. To really maximize the power of dual coding, we have to look at the constraints of the system. This brings us to a related concept, cognitive load theory, CLT, often championed by researchers like John Sweller. While our long-term memory is effectively infinite, our working memory, the mental scratch pad where we process new information, is extremely limited. We can only hold a few chunks of new information at once. If we overload that scratch pad, learning stocks. It's like trying to pour a gallon of water into a shot glass. It just spills over. Here's where the two channels of dual coding become a lifesaver. Because the verbal and visual channels are separate, they have independent capacities in working memory. If you present a complex concept using only text and speech, you are clogging up the verbal channel while the visual channel sits idle. You are creating a traffic jam in one lane while the express lane is empty. By offloading some of that information to the visual channel, you effectively expand the total working memory capacity. You are balancing the load. The split attention effect. However, you have to be careful. Just throwing pictures at students isn't dual coding. It can actually backfire. Imagine a textbook diagram of the human heart. The diagram has letters, A, B, C, pointing to different valves. To understand it, the student has to look at A, then look down to the legend at the bottom of the page to read aorta, then look back at the diagram to see what the aorta looks like. This is called the split attention effect. The student is forced to split their limited mental energy between two sources of information that are physically separated. It creates unnecessary cognitive load. The brain has to hold the image in working memory while searching for the text, integrating them manually. A dual coding approach fixes this by placing the label directly on the part of the diagram it describes. By physically integrating the text and the image, you reduce the mental effort required to process them. The student sees aorta and the image of the aorta simultaneously. The redundancy effect. Another common mistake is the redundancy effect. We see this in bad PowerPoint presentations every day. Picture a presenter who puts a paragraph of text on a slide. Then they stand there and read that exact same paragraph out loud to the audience. This is a disaster for learning. Why? Because the audience is trying to read the text, verbal channel, and listen to the speech, verbal channel, at the same time. These two inputs clash. The brain is trying to process the same information through the same channels simultaneously, causing a bottleneck. A dual coding approach would be to put a relevant image or diagram on the slide, visual channel, and speak the explanation, verbal channel. Now, the audience listens to your voice and looks at the image. The channels complement each other rather than competing.